Okay, now let us go to Introduction to Heat Transfer. The learning outcomes of this chapter will be relation between thermodynamics and heat transfer, distinguish thermal energy from other forms of energy, and heat transfer from other forms of energy transfer. And then perform general electric balance as well as surface energy balances, and understand the basic mechanism of heat transfer, which have three basic mechanisms are conduction, convection, and radiation. And we also learn about Fourier laws and heat conduction, Newton's law of cooling, and the Stephen Boltzmann law of radiation. Identify the mechanism of heat transfer that occur simultaneously in practice and solve various heat transfer problems. Okay, basic principle of the heat transfer. We know that heat is one type of energies or form of energies. It can be transferred from one system to another due to temperature difference. We already learned about first law of thermodynamics and second law of thermodynamics. And thermodynamics deals with amount of heat transfer as a system undergoes a process from one equilibrium state to another equilibrium state. And heat transfer is concerned with the determination of the rates of energy or the heat transfer as well as the variation of temperature. Means that different temperature, different heat transfer can go on. Okay, basic principle of heat transfer. Uh, we know about the heat transfer is always from higher temperature to a lower temperature, so the heat can be transformed. And heat transfer is not occur if two mediums have the same temperature. But if you want to transfer heat from low to high temperature, we should use heat engine or cooling system. And there's three modes of heat. It can be transferred with conduction, convection. Conduction means from the solid or metal. The stokeman heats the kettle and the kettle heats the water by conduction. So the kettle walls here is metal. It can heat the water by conduction because water and metal is touching each other, and water circulate in the kettle. Water is circulating in the kettle, so the kettle transfer heat by convection. And then near the stove, the air would feel warm due to heat transfer by radiation. Okay, we will learn detail about the importance of heat transfer. In almost every branch of engineering, heat transfer problems are encountered which cannot solve by thermodynamic process alone, but require an analysis based on the science of transfer. In electrical engineering also, design of cooling system for motor, generators and transformer should use heat transfer. In chemical engineering, concept of evaporation, condensation, heating and cooling of fluid, also we have to know about heat transfer. For civil engineering, they have to understand the law of heat flow. It is important in the construction of dams and structures. And in mechanical engineering, of course, internal combustion engine, steam generation, refrigeration, heating and ventilation. Architecture, they have to know heat transfer when they are making design of buildings. Cost estimation and feasibility and size equipment is necessary to transfer a specified amount of heat in a given time. So you have to know the detail of heat transfer analysis. Okay, application areas of heat transfer. I think I've explained about air conditioning system, and then power plants, refrigeration system, same as aircon. Electronic equipment, maybe to take a heat from the printed circuit board or any IC that produce heat during operation. Okay, power plants. This one, any power plants, if they are using coal, diesel, gas, natural gas, or in fact nuclear power also are related to heat transfer. The forms of energy is usually in thermal energy, kinetic energy, potential, electrical energy, magnetic energy, chemical energy in battery, nuclear energy also. There are some constitutes the total energy, or E, unit mass, energy for unit mass of a system, and the sum of all the microscopic form of energy is called the internal energy. So what is internal energy may be viewed in the sum of kinetic and potential energies of the molecule. Sensible heat, this is a kinetic energy of a molecule. Latent heat is the internal energy associated with the phase of a system. Chemical energy, the internal energy associated with the atomic bonds in a molecule. And for nuclear energy, the internal energy associated with the bonds within the nucleus of the atom itself. We will discuss this later detail in the next part. Okay, internal energy and enthalpy. What is internal energy? It's a microscopic energy of the non-moving fluid. But if you are moving in a moving fluid, you will have enthalpy. It is microscopic energy of the moving fluid, where usually enthalpy is internal energy plus pressure times specific volume. So PV cover the flow energy or flow work of a fluid, which is the energy needed to push a fluid to maintain flowing. Yeah. Okay, in a specific heat, the energy needed to increase the temperature of a unit mass of a substance by 1 degree. There's two types of specific heat. One is in constant volume, or CV. Yeah. Another one is specific heat at constant pressure, CP. In general, it depends on two dependent properties, that is temperature and pressure. At low pressures, all real gases approach ideal gas behavior, and therefore their specific heat depend on the temperature only. For example, 0.5 kilojoule of energy is needed to increase the temperature in this iron block to 26 degree in a specified way, from 25 to 26 degree. So the specific heat of a substance will change with temperature. Air, for example, if you want to take to 1 degree at 300 degrees Celsius to 301 degrees Celsius, you need about 0.78 kilojoule. But the same mass of air, if you want to increase 1 degree at 1000 degree, you need more than 0.78 here. that is 0.855 kilojoule. So then the specific heat is changed with temperature. Incompressible substance, a substance with specific volume or density does not change with temperature or pressure. In other words, the CV and the CP are identical for incompressible substance. The specific heat of incompressible substance depend on temperature only.